It took one look, then forever lay out in front of me. One smile.
At what time will I reach her with this velocity?
To be revived.
I will measure the first 50 feet she traveled before she starts. She reached 50 feet in 8.15 seconds, so her velocity is her distance traveled divided by the time, which is 6.13 feet per second. I reached the same distance in 5.2 seconds, so my velocity is 9.62 feet per second. We can now solve the acceleration using this equation. We have no initial velocities, so they are zero. And by substituting, we got. So I can now solve the time to reach her. We let the point where we will reach as distance x from the 50 feet mark, then we will use this another equation to describe our motion. Her motion will be described by this equation. Initial velocity is 0 and x for distance she will travel until we meet. And for my motion, the distance I need to travel is 50 feet plus the x distance that she will travel. And by solving for time, I will reach her at 13.48 seconds. Hi.
Hi.
Oh, hey Josh, so you have awoken. Here's our new neighbor cat. She wants to know the place more. So would you mind showing her around for tomorrow?
Okay, Dad. Hi. Nice to meet you.
Hi. By the way, I have to go now. See you tomorrow.
Bye.
Bye.
Okay, Dad. I'll just take it back. Okay. Cat wonders, if three people with different mass uses the swing, the lighter one will be faster and the heavier one will be slower. Let's see what will happen. We analyze all the forces acting on them. The angle of the chains is approximately 25.5 degrees. Their weight, or the product of mass and acceleration of gravity, will be acting downward, and the tension provided by the chain can be represented as its x and y components. Applying Newton's second law, there will be no motion in the y direction, so the sum of all forces there must be zero. The motion is on the x direction, so the sum of forces there must be equal to mass of the objects times acceleration. Equating the tension, masses will cancel out. Theoretically, mass doesn't affect the acceleration. But in real life, there will be deviation since friction on the chains and air resistance is present. In our computations, we assume that the other factors is not present. She asked me again, does the man in the swing will never stop? Let's prove it using the law of conservation of energy. The initial energy must be equal to its final energy. K stands for kinetic energy or moving energy, while U is potential energy or energy due to position. At max height, we will eventually stop making K equals to 0 and U is maximum. At minimum height, the object U equals 0 since height is 0 and all the potential energy becomes kinetic energy. So this is the relation of the person's initial and final energies. If we do the initial and final energy analysis again, the same equation will be obtained. Since in our computation, everything is ideal, no energy will be lost. Theoretically, he won't stop if no other forces exist. In real life, his speed will decay for a very long time. So this is a fast-forward preview.
Come on! See this! I'll drop it, same time, game. 1, 2, 3, yeah!
Tulog ka na.
One more time! Oh, this one. Okay, you want to see? See this?
Yeah.
1, 2, 3! Okay, thank you, man. Okay, go. See this two balls? Oh, same balls! Yeah! P1 and P2, not the same mass! Heavier, lighter. Oh, yeah. Now see this? They will fall the same time. Look, oh, not yet. See this. 1, 2, 3.
Relax, boy.
Heavy, not heavy. Come on.
Okay.
3, 2, 1. 3, 2, 1. Yeah! Come on, thank you. Bye-bye.
Why different balls dropped in same height will fall the same time? Using kinematic equation, there will be no initial velocity because the ball is dropped. Height will be the same and acceleration on both balls is gravity, so they must have the same time. Let's conduct an experiment. We will drop it on a height of 9.25 meters. and perform 3 trials to measure the time it takes to fall. By getting the average of the measured time, substituting the values of the equation, theoretical time is 1.373 seconds.
Look up! Here comes!
She asked me what is the effect of having a frictionless slide. First, we apply powder on the slide to remove the contact friction. Then measure the appropriate dimensions of the slide. We can solve the angle of the slide by applying cosine function. Then we analyze the force acting on them. Only their weight will be acting on them since we remove friction. By representing the weight by its components and applying Newton's second law, the motion will be at the x-axis. So the sum of forces there will be equal to m times a. The only forces there is the x component of the weight, and by solving for acceleration, since masses are cancelled, all of them theoretically must have 17.28 feet per second squared acceleration. Let's measure the time taken to travel 8 feet. We check it using kinematic equation and substitute the acceleration and time. The theoretical distance is 8.09 feet. Will I see you again?
Yes.
Thank you for joining us on our fun-filled dynamics adventure.
Ba't maka-iya? Square bearing na yan. Walang seller tayo.